One thing you may know about calculus is that it's the branch of mathematics that deals with the finding and properties of derivatives and integrals of functions. Or so the dictionary says. But what does that mean? What can you do with calculus? Well, I'm glad you asked. Calculus can be used to do a whole assortment of things, from finding the area between curves to determining, you know what? Scratch that. Let's say you wanted to know the length of the arc upon hitting a birdie. That's a lot more exciting, isn't it? In the real world, you would need to know a bunch of things to be entirely accurate, like the air resistance caused by the birdie, the angle the racket makes with the birdie, and the direction and speed of the wind. But who cares about those? It's such a drag, so I'll be ignoring them. Or more realistically, incorporating that would make this more of a physics video than a calculus one. Anyways, the birdie will be a two-dimensional point. The world will lack resistance of any kind, so no friction or air resistance. The mass of the birdie and racket are identical, so more or less I'm ignoring them. And the birdie makes a 45-degree angle with the ground after being hit. Here's some other things that we'll need to know in order to determine the birdie's path. Well, with that out of the way, it's time to start with the calculations. First, we'll determine the velocity of the birdie in the x and y directions. Since we know that the birdie moves at 10 meters per second, making a 45-degree angle with the ground, we can separate the x and y velocities, getting 7.07 meters per second for each. This was found by multiplying 10 by sine 45 degrees for the y and cosine 45 degrees for the x. They're the same since this is a 45-degree angle. If it was something else, then our numbers would be different. There's no resistance, so the birdie will continue moving along until it hits the ground, which is our stopping point for this question. This is modeled by the equation x equals 7.07 times time. Similarly, the equation for the y position is found through the equation y equals 7.07t plus 1/2 times negative 10 times t squared. These equations were found using basic principles of kinematics for the sake of saving some time. Since we're not really going into the physics of this here, I'm just gonna skip it and we'll continue. Sound good? Great. You could use these equations to find many different things, but in this case we really just want to know an equation that relates the distance traveled along the y-coordinate to that of the x-coordinate. As you might be able to guess, this will result in an upside-down parabola because gravity is causing the birdie to accelerate downwards. We can figure this out by rearranging the equation for the x component to t equals x over 7.07, and then plugging that into the equation for the y position. If you graph it, you'll see a nice curve that portrays the path of the birdie, with the stopping point being the moment the birdie passes the starting y position. We can solve for when y equals 0 to find that the x position will be at 10 meters at the end of the path. And now for what we came here for. The arc length of a parabolic arc is determined by the integral from a to b of the square root of 1 plus the derivative of the equation squared. The derivative of the equation is 1 minus 0.2x, which means the arc length is 11.478 meters. There you go. Just like that, we now have the length of the arc of the birdie, or rather, the point traveled after being hit by the racket. I hope you all enjoyed another educational calculus video. Wait, what? The video was all about badminton? How's that even possible? This was supposed to be the crash course to calculus.